The last class, we have discussed some of the scheduling algorithms. In that, FCFS and shortest job first algorithms, which we have discussed previously. So in the FCFS, first come first serve algorithm, what happens? Whatever the order that the processes are arrived into the job queue are allocated to CPU. Okay, so whatever the burst time that they require, according to that, CPU will process the processes. And there we have calculated waiting time and as well as turnaround time. Based on the values, we'll try to calculate the average waiting time and as well as average turnaround time. So in the FCFS, the problem which we have observed is, suppose if the first job is the longest among all other jobs, what happens in that case? It takes a lot of time for its execution. Meanwhile, all other processes, even though they are short in size, they need to wait until the completion of the long job. So waiting for a long period of time is called as starvation. Okay, so the remaining processor gets starved. So that is the reason in the SCF itself, instead of allowing the long jobs first, based on the size, we'll allow the shortest one as the first one, irrespective of the number of processes which are available. Okay, so irrespective of the time they arrived, so just simply whatever the shortest job that is present in the queue at that moment will allow first. Okay, so based on the size, we'll allow one after another. Okay, so in this, what happens again? The longest job, the shortest job gets executed first, but whereas the longest job need to be wait for a long time. Okay, so these two are non-preemptive scheduling algorithms. Non-preemptive in the sense there is no forceful exit or termination in between the execution of a process. So such kind of scheduling algorithms are called as non-preemptive scheduling algorithms. So even the SJF, the shortest job first algorithm, can also be implemented in preemptive, can also be implemented as preemptive scheduling algorithm. So that is what we are call it as shortest shortest remaining time first, based on the shortest remaining time. So remaining time that is required to complete its execution. Okay, based on that, we'll allow the processes to execute. Now, actually, we have started discussing example on it. So we'll continue that. Okay, so just a minute. Process. So in this, up to now, what we have considered is all of the jobs are arrived at zero time. But now we need to have the arrival times of all the processes. Arrival time. Okay. So don't think about the writing and all. All of you try to understand what is the concept itself. Okay. And burst time. Burst time means the time actually required, how much of time it requires the services of CPU, then waiting time, and then turnaround time. Okay. Yeah. First, let us look at about the processes which are in the queue. P1, P2, P3, and P4. So imagine the arrival times are like this: 0, It may not be the same. The arrival times may be different for the problem which you have considered. Okay, just for our convenient, I was assumed like this. Okay, not always the arrival time should be the same. Then the burst time is for process 1 is 8, and for process 2 is 4, process 3 is 9, okay, and process 4 is 5. Now here our concept is whatever the time that they arrived, based on that we will decide which process is the shortest one. So usually if you try to implement HF, what we consider whatever the shortest burst time. Here the P2 will be allowed first, and then P4 will be allowed, after that P1, after that P3. In such a order we'll process all these processes. Okay, but here what happens is initially let us talk about the ready queue, because here the times are given, arrival times are given. Okay, ready queue. Initially P1 has arrived. Now we'll try to draw the Gantt chart for it. Okay. Right. So what is the first process that was arrived into the queue? P1. Okay. P1 will be placed here. How long it could be executed? For 1 millisecond. Because after 1 millisecond, P2 has arrived. So that is the reason from 0 to 1, P1 has processed. After 1 ms, what are the processes which are present in the queue? P1 has already arrived, and then P2, right? So now after 1 millisecond, that means how much of P1 has processed? 1 millisecond of time has processed. So what is the remaining one? 7. So now what is the burst time of C process 2? 4. Among these two, which one is the shortest one? Process 2 is the shortest one. So we'll stop the execution of P1. We'll stop the execution of P1 and we'll allow process 2 for execution. Okay, all of you understand? Once again, I'll repeat the same. Initially, P1 has arrived into the queue at the 0 arrival time. So at that moment, no more process is present in the queue. That's why directly we'll allow the P1 per processing. After 1 millisecond, P2 has arrived. After 1 millisecond, P2 has arrived. So at that moment, we need to be allow only the shortest job, because we have 2 jobs. Among those 2, we need to allow only one process, which is the shortest among those 2. So now already we have processed P1 for 1 millisecond. So that is the reason the remaining is 7 milliseconds. That is the reason shortest remaining time first. Whatever the remaining time among these 2, which one is the shortest? Process 2 is the shortest one. So that's why we will allow process 2 for the execution. All right. So after 1 millisecond, so we need not require. After 2 milliseconds, after 2, what are the processes which are present in the queue? P1, P2, P3. Okay. So here after 1 millisecond, what will be the remaining? Because P2 has processed for a period of time how much? 1 millisecond. So we'll reduce it from the actual time. 4 minus 1, 3. Fine. And after that, P3 has arrived. Now, what are the burst times of the processes which are present in the queue? P1, P2, P3. P1 burst time is 7, P2 burst time is 9, and P3 burst time is, sorry, P2 burst time is 3, P3 burst time is 9. So, among these three, 9, 7, 3, 3 is the shortest one. So, that's why we will continue the process after 2 milliseconds also. And now, after 3 milliseconds. Okay. What are the jobs which are present in the queue? You can observe how do I say this is the arrival time. Based on this, I'll prepare this ready queue, right? P1, P2, P3, and P4. Okay. Now all the processes are present in the queue. So now let us verify. After 1 millisecond, that means it was reduced to 2. Right. After 3 milliseconds, all the jobs P1, P2, P3, P4 are available in the ready queue. Now you need to be checked out what is the shortest among these two. Now you need to compare 7, 2, 9, 5. Among these four, again 2 is the shortest one. So that is the reason we'll continue the execution of the P2 till its completion, because no other job is shorter than this P2. So what is the time required for P2? 4 milliseconds. So 1 plus 4, it becomes 5. And after that, you need to compare. Anyway, process 2 has completed its execution. Now, what are the remaining? P1, P3, P4. Among these three, P1 has the burst time as 7, whereas P3 is 9 and P4 is 5. So, among these three, P4 is the shortest one. So, that's why we'll allow P4 for the execution. So, how much time it required? 5 plus 5, 10. And then, among these two, P1 is the shortest one. How much time it requires? 7. So, 10 plus 7, 17. And at last, P3 will be executed because it is the highest burst time. 17 plus 9, 26. Okay. Now, here you cannot write waiting times based on the Gantt chart. Previously, we just looked at about the left side values of the process for representing the for recording the waiting time. But here P1 has repeated 2 times. So which value are supposed to be considered? Whether we consider this one or whether we consider this one. So there is an ambiguity. So that's why we need to be calculate the waiting time with a different formula. That is whatever the last cycle that P1 has executed. So for this waiting time is 10 minus, okay, and whatever the last cycle that it was executed. How many cycles it was executed? Already previously 1 time it was executed. So that is the reason we need to subtract it. Minus the arrival time, 0. So here waiting time formula, all of you note down. The last cycle waiting time, last cycle waiting time in the sense, whatever the recently executed waiting time of that particular process. That is here, for as far as concerned with the P1, this is the latest cycle. So the waiting time of this process 1 is 10 minus how many number of cycles it was completed? Only 1 cycle. So that's why minus 1 minus arrival time. So how much it will become? 9. Similarly, for P2, what is the waiting time of P2? 1 minus how many cycles did it have completed? No, 0 minus arrival time is 1. So that becomes 0. That means what it indicates is 0 means whatever the time that it was arrived, immediately we are allowed that particular process for the CPU execution. That is the meaning of 0 here itself. Okay. Now coming to the process 3, 17 minus Is there any previous execution? No. 0 minus what is the arrival time? 2. So 17 minus 2 is equals to 15. Okay. And then coming to the P4, 5 is the waiting time of P4 minus previously it was not executed even single time, 0 minus arrival time is equal to 3. So it will become 2. Now what will be the total time of this one? 9 plus 15, 24 plus 2, 26. Okay. AWT is equals to 26 by 4. That is equals to 6 4s are 24 plus 20. I think 6.5 milliseconds, right? 6.5 milliseconds. Is it correct? The calculation 26 by 4 is equals to 6.5, right? Okay, no problem. Now, turnaround time. As you are aware of that, turnaround time is equals to burst time plus waiting time, right? So now, 8 plus 9 is equals to 17. Okay. And 4 plus 0, 4. 9 plus 15, 24. 5 plus 2, 7. What will be the total value? 17 plus 4, 21. 21 plus 24, 45. 45 plus 7, 52. Average turnaround time is equals to 52 by 4 is equal to how much? 13, I think. Right? Right? So, somebody has some doubt. Okay, 13, thank you. Right. So, in such a way, we can implement HF as a preemptive, then the name will be changed because here the phenomena has changed. The shortest remaining time first. So, what are based on the arrival time will allow the processes for execution based on the shortest, based on the processes shortest burst time. And another important point here you need to observe is once all the processes are placed in the queue, it will act as just like acts as a HF. There is no differentiation. You can observe this point. చూడండి ఇక్కడ P1, P2, P3, P4 4 కీలోకి ఎప్పుడు వస్తున్నాయి? ఆఫ్టర్ 3 మిల్లీ సెకండ్స్ తర్వాత వస్తున్నాయి. సో 3 మిల్లీ సెకండ్స్ తర్వాత మనం ఏం చూసాం? ఇంకా ఏదైతే షార్టెస్ట్ జాబ్ ఉందో దాన్ని ఎగ్జిక్యూట్ చేసుకుంటూ వెళ్ళిపోతుంది. ఇక్కడ మనకి ఇంకా రిమైనింగ్ 2A ఉన్నాయి కాబట్టి మనకు తెలియలేదు. అఫ్ కోర్స్ ఇంకా మోర్ దాన్ దట్ ఉంటే ఏమవుతుంది? ఇంకా అక్కడ నుంచి వన్స్ ఇవన్నీ క్యూలోకి వచ్చేసిన తర్వాత ఓన్లీ విల్ వెరిఫై, విల్ చెక్ ద షార్టెస్ట్ అమాంగ్ ది రిమైనింగ్ జాబ్స్ అండ్ దెన్ విల్ అలో కంటిన్యూస్లీ. ఇప్పుడు ఇక్కడ P4 వచ్చేసిన తర్వాత ఏం చూసాం? ఇంకా మనం రిమైనింగ్ జాబ్స్ ఏమి ఉన్నాయి? P1, P3 ఉన్నాయి. P1లోకి షార్టెస్ట్ ఉంది కాబట్టి P1 అలో చేసాం. ఆఫ్టర్ కంప్లీషన్ ఆఫ్ P1, P3 will be executed. Right? Like that. Once all the processes are placed in queue, it will act as a SJF. Right? ఇక్కడ దీన్ని ప్రియంటివ్ అని ఎందుకన్నాం? ఫస్ట్ ప్రాసెస్ 1 స్టార్ట్ చేసాం, ఎందుకంటే అప్పుడు ఆ టైంకి మిగతా ప్రాసెస్లు ఏం లేవు కాబట్టి. ఎప్పుడైతే 1 మిల్లీ సెకండ్ తర్వాత P2 వచ్చిందో, P2 యొక్క బర్స్ట్ టైము P1 యొక్క బర్స్ట్ టైము మనం కంపేర్ చేస్తే P2 అనేటువంటిది షార్టెస్ట్ ఉంది కాబట్టి P1 యొక్క ఎగ్జిక్యూషన్ సస్పెండ్ చేసి ఫోర్స్ఫుల్లీ విల్ సస్పెండ్ ద ఎగ్జిక్యూషన్ ఆఫ్ P1 అండ్ దెన్ విల్ అలౌ ది P2 ఫర్ ఇట్స్ ఎగ్జిక్యూషన్. సో ఎక్కడైతే ఇలాంటి టెర్మినేషన్ జరుగుతుందో దాన్ని మనం ప్రీఎంప్షన్, బిఫోర్ కంప్లీషన్ ఆఫ్ ఇట్స్ ఎగ్జిక్యూషన్ ఇట్ వాస్ ఎగ్జిటెడ్ ఫ్రమ్ ది ఎగ్జిక్యూషన్ ప్రాసెస్ ఏదైతే ఉంటుందో దాన్ని ప్రీఎంప్షన్ అంటున్నాం. ఇక్కడ మనం ఫాలో అవుతున్నటువంటి పారామీటర్స్ దృష్టిలో పెట్టుకుని ఆ పారామీటర్స్ కారణంగా దీన్ని సస్పెండ్ చేయడం జరిగింది. సస్పెండ్ చేసి ఏం చేస్తాం మనం, will allow the next shortest job for its execution. P2 will be executed. After that, again, we'll check the remaining burst times. Shortest remaining burst times. దేనికైతే షార్టెస్ట్ టైం ఉంటుందో ఆ ప్రాసెస్ను మనం కంటిన్యూ చేస్తూ ఎగ్జిక్యూషన్ చేయడం జరిగింది. సో అందుకని ఈ షార్టెస్ట్ రిమైనింగ్ టైం ఫస్ట్ అంటే అది. సో ఎవరైనా అడిగారు అనుకోండి SJF is what kind of scheduling algorithm it is అని. సో అక్కడ మీరు చెప్పొచ్చు. సో SJF is a non-preemptive scheduling algorithm. Even we can implement it as a preemptive scheduling algorithm by considering it as shortest remaining time first. Using that principle, we can make it as preemptive scheduling algorithm. Hope you are all clear with this point. Is it clear to everybody? If you have any queries, you can ask. Can I go ahead with the next one algorithm? Okay, thank you. Now, all right. So the next algorithm is priority scheduling algorithm. Priority scheduling algorithm. As I told you, there are several types of processes are present in the main memory, like operating system processes, application processes, and as well as user processes. So among all these things, operating system processes are having highest priority. So here priority means we'll give the importance VIP and an ordinary person. Like that, for each and every process will be assigned with a priority. Based on that priority, it allow you for the execution. So whatever the highest priority, here highest priority will be represented with 1. Okay, next priority will be 2. So whatever the least integer value that a processor will have is having highest priority. Okay, so whatever the highest priority process is present in the queue, that will be allowed for the execution. In such a way, based on the priority, will allow the processes for its execution. In that case, whether it is longest job or shortest job, there is no differentiation. Whoever is having the priority, that process will be executed. Right? So let us see an example for the priority scheduling algorithm. Process time, burst time, and then priority. Okay, right. So let us assume that the processes are P1, P2, P3, P4, P5. Okay, and the burst times are like this: 10, 1, 2, 1, and then 5. These are the burst times of two, 5 processes, and the priorities are 3, 1, 4, 5, and 2. So we need to calculate waiting time and as well as turnaround time. Okay, now let us draw the Gantt chart. So don't think otherwise. I am poor in drawing. Okay, even though the shapes are different, please bear me for this time. Fine. So here our concept is whatever the priority, whatever the process which is having highest priority, highest will be represented with the least number. Don't forget it. Here, highest priority means 5 is not highest priority. 1 is the highest priority. Okay. Right. Whatever the process which is having highest priority will get executed first, and then the next priority one. Like that, among the highest priority one, among all other processes will get executed. దేనికైతే హైయెస్ట్ ప్రయారిటీ ఉంటుందో ఆ జాబ్ ఫస్ట్ ఎగ్జిక్యూట్ అవుతుంది. అలా ప్రతిసారి కూడా ఉన్న అవైలబిలిటీ ఉన్నటువంటి రెడీ క్యూలో ఉన్నటువంటి ప్రాసెసెస్ లో ఏ ప్రాసెస్ కి అయితే హైయెస్ట్ ప్రయారిటీ ఉంటుందో ఆ ప్రాసెస్ ఎగ్జిక్యూట్ అవుతుంది. సో ఇప్పుడు ఇక్కడ మనం కనుక అబ్జర్వ్ చేస్తే P1, P2, P3, P4, P5 ఇక్కడ ఈ 5 ప్రాసెస్ ఒకే టైంలో అరైవల్ అట్ 0 టైం అని మనం కన్సిడర్ చేస్తాం. ఒక ప్రీఎంప్టివ్ షెడ్యూలింగ్ అల్గారిథమ్స్ కు మాత్రం ఆ టైం ఇంటర్వెల్ కూడా క్యాలిక్యులేట్ చేయడం జరుగుతుంది. ఇందాక మనం చూసాం SRTF లో బేస్డ్ ఆన్ టైం ఇంటర్వెల్ అరైవల్ టైంను బట్టి మనం క్యాలిక్యులేట్ చేయడం జరిగింది. ఇక్కడ ఇట్ ఈస్ ఏ నాన్ ప్రీఎంప్టివ్ షెడ్యూలింగ్ అల్గారిథం. అంటే వన్స్ మనం ప్రాసెస్ అలొకేట్ చేస్తే అది కంప్లీట్ అయిపోయేంత వరకు దాన్ని టెర్మినేట్ చేసే టైం ఉండదు. కాబట్టి ఇది నాన్ ప్రీఎంప్టివ్ షెడ్యూలింగ్ అల్గారిథం అవుతుంది. ఓకే, సో ఇప్పుడు ఉన్నటువంటి ఈ 5 ప్రాసెసెస్ లో P1, P2, P3, P4, P5 లో హైయెస్ట్ ప్రయారిటీ దేనికి ఉంది? P2కు ఉంది. సో కాబట్టి మనం ఫస్ట్ ఎవరిని అలో చేయాలి? P2 హ్యాస్ టు బి ఎగ్జిక్యూటెడ్ ఫస్ట్. ఓకే, ఎంత టైం కావాలి దానికి? బర్స్ట్ టైము 1 millisecond. సో ఆఫ్టర్ దట్ what will be the next highest one? P5. నెక్స్ట్ హైయెస్ట్ ప్రయారిటీ 1 కంప్లీట్ అయిపోయింది. 1 కంప్లీట్ అయిపోయిన తర్వాత ఇంకెవరు? 2. సో P5కి ఎంత టైం కావాలి? 5 నానో మిల్లీ సెకండ్స్ కావాలి. 1 + 5 ఇట్ విల్ బికమ్ 6. సో ఇది కూడా అయిపోయింది. నెక్స్ట్ P1. So how much time it required? 10 milliseconds. So now it will become 16. After that, P3. So P3 requires 2 milliseconds. So 16 + 2, it will become 18. And after that, the last one is P4. Right? So P4 requires 1 millisecond. So that's why it will become 19. Okay, so these are the times which we have calculated. Just a minute. So have we calculated the waiting time? So how do we calculate the waiting time? Directly you can write. As for P1, what is the time that it need to wait? 6 milliseconds. Coming to P2, no need to wait 0. P3, 16 milliseconds. P4, 18 milliseconds. P5, 1 millisecond. Now what will be the total? 22, 30, 40, 41. Right? 41 by 5. That is equal to how much it will become? 8.2, right? 8 4 are 8.2, right? So turnaround time. Coming to the turnaround time means burst time plus waiting time. 10 plus 6, 16. 1 plus 0, 0. 2 plus 16, 18. 1 plus 18, 19. 5 plus 1, 6. Okay. Now 16 plus 18. 16 plus 18, 20, 34, 44 plus 9, 53 plus 6, 59. Average turnaround time is 59 by 5. How much you can calculate? How much it will be? 59 by 5. 10 5s are 50. 11.8. Right? Sorry. Here we need to add one more value. 1 plus 0. This is 1, right? This value is 1. Okay, yes, you're right. Because here I forgot, I just recorded as 0. So now it becomes 1. So altogether it becomes 60. It will become 60. So 60 by 5, 10. Okay. So average turnaround time is 10. So in such a way, the priority scheduling as processed, it's a processes. So here what we have observed is whatever the process which is having lowest priority will get starved. For example, here let us assume that P1 is having the priority has 10. Let us assume that. Okay. So meanwhile, so many, even though it was arrived first, 60 by 5, 12. Yeah. You are correct. You are correct. Not 10. You are correct. It is 12. 12 5s are 60. Sorry for. Yes. You are correct. Yes. Sorry for that. 60 by 5 is 12. You are correct. Okay. Now, here, let us assume that process 1 is having the priority at 10. What happens in that case is, whatever the processes, suppose P2 has priority as 2, P3 has priority as 1. Same priority. Yeah, good question. Good question. If two processes are having the same priority, it will be processed based on the time of arrival. That is first come, first serve. Whatever the process that they arrived first, that will be processed first. If they have same priority, for example, instead of P5, here the value is only 1 instead of 2. Okay. Yeah, we'll make priority scheduling as preemptive. Very soon we are going to be, after completion of this, we'll see how it could be implemented as a preemptive. Fine. Okay. Suppose if it is 1, what happens in that case? Both the processes are having same priority. So in order to avoid the ambiguity, what they did is, whatever the process which was arrived first. So suppose if you assume that P1, this is the order which they arrived. So among these 5 processes, P2 and P5 are having the same priority, but P2 has arrived first and P5 has arrived later. So that is the reason first it was processed P2. After that, P5 will be processed, even though it was arrived at last. Because of this priority, highest priority, it was processed next. Hope you are all clear with this point. Okay. So if two processes are having same priority, based on the order that they arrive, it will be processed. First come, first serve. Right. Now another here the drawback which we are going to be discussed is, suppose if process P1 is assigned with the priority as 10, in that case, all other lowest priority tasks are getting executed continuously. Okay. But even though it was arrived first, it need to wait until last. Okay. So in that case, suppose assume that some other processes are frequently arising, some operating system processor frequently they are arising. Okay, what happens in that case? There is no chance of getting executed P1. సో దానికోసం ఏం చేస్తారంటే ఈ P1 ఇంకెప్పటికీ ఎగ్జిక్యూట్ అయ్యేటువంటి సందర్భం ఉండదు కాబట్టి దాన్ని ఏం చేస్తామంటే దీనికి ఒక సొల్యూషన్ ఏంటంటే ఏజింగ్. ఏజింగ్ అంటే ఏంటంటే విల్ డిక్రీజ్ ద ప్రయారిటీ లెవెల్. అంటే ఫస్ట్ 10 ఉంది కదా, ఓ పీరియడ్ ఆఫ్ టైం తర్వాత, అంటే ఒక హాఫ్ అన్ అవర్ ఎంత వెయిట్ చేసిన తర్వాత కూడా అది ఎగ్జిక్యూట్ కాలేదనుకోండి, విల్ రెడ్యూస్ ద ప్రయారిటీ టు ద 9. Again, we'll wait a period of time. Still, it was not executed. We'll reduce the priority. Like that, it will be reduced its priority. Okay. Suppose once it will reduce it to 6, probably it may get executed. If it is executed, then fine. Otherwise, we'll continuously decrease the priority based on the time quantum. So certain period of time will fix. So after completion of that period of time, still if it was not executed, we'll reduce the priority. Like that, we'll continue the process. So definitely, for a period of time, what happens? The priority of this one becomes 1. When you are continuously decreasing it like this, for a period of time, definitely the priority of this process will become 1. In that case, definitely it could be executed. So in such a way, we'll make the highest priority process could be executed with the help of aging. This concept is called as aging. Okay. So in such a way, the priority job scheduling algorithm can be implemented. This is a non-preemptive scheduling algorithm. Now, let us see the preemptive version of this same process. Is it clear? Still, if you have any queries, you can ask. Because I think you understood very well, so that's why I'll just move a little bit faster. Still, if you are not able to understand, we'll make it slow and we'll discuss elaborately based on your doubts. Now, let us talk about preemptive. Okay. Now, so process, when you are dealing with preemptive, we need to be utilize the arrival time and burst time, waiting time, turnaround time. Okay. Now, let us look at about the processes. P1, P2, P3, P4, P5. Arrival times are in the order 0, 1, 2, 3, 4. Okay. So the priorities, sorry, I forgot. Actually, this is the priorities are 3, 4, 1, 4, 5, 2. Now, as the way the shortest remaining time first, here also we'll see based on the arrival time, we'll calculate there, we'll look at about the shortest job. Here we'll look at about the priorities. Whoever is having the highest priority will be allowed first. Okay. Hope you understood. So initially, P1 has arrived. At that moment, no more process is available in the queue. So that's why we will allow it for the execution. After 1 millisecond, what are the processes are available? You just write Did you calculate it? Anybody has calculated or draw the Gantt chart? If any one of you completed this task, you please unmute yourself and tell me. No problem. Whether it is right or correct, no issue. Whether it is right or wrong, no issue. You just unmute yourself and you can tell me what is the process, because I think you got an idea how it could be executed. Anybody else? Okay, and the time is running away, so I'll try to conclude this. So after 1 millisecond, P1, what are the jobs that are, what are the processes which are present in it? P1 and P2. So among these two, which one is having the highest priority? When we are looking about the priorities of these two jobs, P2 has highest priority. So we'll suspend the execution of the P1 and we'll allow P2 for its execution. How much time it would require? 1 millisecond. Okay, let us see. After 2 milliseconds, what are the processes? P1, P2, P3. Right? So among these three, P1, P2, P3. Among these three, which one is the highest one? P2, which has already completed its execution, because one has completed. So now what are the remaining? P1 and P3. Okay. Sorry. I did not note down the, just a minute, just small mistake. Not a mistake. We need to note down the boss times first. Same in the previous example, you can take 10, 1, 2, 1, 5. Okay. So P1 has processed how much of time? 1 millisecond. So that's why it was remaining 1. Anyway, P2 is only 1 nanosecond it required. So that's why it was completed. So after 2 milliseconds, what are the processes which are present in the queue? P1, P2, P3. Among these three, P2 has completed its execution because it requires only 1 nanosecond. Remaining are 3 and 4. Among these three, which one is the highest priority one? P1. So P1 is continued with its execution. P1 is allowed for the execution. Right? After 3 milliseconds, P1, P2, P3, and P4. Right? P1 still has executed one more time. So among these three, P1, P2 anyway it was completed, P3, P4. Among these three, again P1 has the highest priority. So that's why it was continued with its execution. After 4, we'll have 1, 2, 3, 4, 5. Right? So now it has completed 1 more millisecond. So that's why it will become 7. All right. Now P2 has completed its execution. Okay. Among these, what are the remaining processes are available in the queue? P1, P3, P4, P5. P1, P3, P4, P5. So among these three, what is the priority that it will have? 2 is the highest priority that it will have. So that is the reason it could be executed. How much time it was processed ikkada? P1 and say process ayindi ikkada. Already 1 nanosecond ikkada ayipindi. Remaining 2 nanoseconds జరిగింది ఇక్కడ ప్రాసెస్. అంటే 2 + 2 ఎంత అయింది? 4 అయింది. 4 అయిన తర్వాత P1, P3, P4, P5 లో P5 అనేటువంటి దానికి హైయెస్ట్ ప్రయారిటీ ఉంది కాబట్టి P5 అలౌ చేస్తుంది. సో ఇంకేమన్నా క్యూలోకి జాబ్ ప్రాసెస్ రావాల్సి ఉందా? ఇంకేం లేదు కాబట్టి డైరెక్ట్గా ఇట్ విల్ బి ఎగ్జిక్యూటెడ్. సో ఇది కంప్లీట్ అయిపోయింది. సారీ, ఇక్కడ అంతా దీనికి టైము 5 కదా, 4 + 5 11 అవుతుంది. బాస్ టైమ్స్ చూసుకోవాలి మనం. ఇక్కడ 11 అవుతుంది. సో ఇది కంప్లీట్ అయిపోయిన తర్వాత ఇంకేమైనా ప్రాసెస్లో P1, P3, P4. సో నౌ విల్ అలో P1. ఇంకెన్ని ఉన్నాయండి ఇక్కడ? 7 ఉన్నాయి. 7 నానో సెకండ్స్ ఉంది. 11 + 7 18. ఓకే. నెక్స్ట్ P1 తర్వాత ఇంకేమన్నా P3, P4. సో దాంట్లో P3 హైయెస్ట్ ప్రయారిటీ కాబట్టి దానికి 2 నానో సెకండ్స్ అవసరం అవుతుంది కాబట్టి 20. సో లాస్ట్ P4 will get a chance. This requires 5. Total it will become 25. Okay. So this you can practice at your home, and in the next class we'll continue the remaining things because time is already over. The next class is supposed to start at 9:30. Now it will become 9:26. Okay. Right. So you just get prepared and practice all these problems at your home, and still if you have any queries, we will discuss it in the next class itself. Okay, or you can personally drop a WhatsApp to my number. No issue. If you have any queries, you can drop a message in WhatsApp also. Right? Thank you. Thank you very much.